This video, we're going to prove that if u and v are in R2, u dot v is equal to 0 if and only if those two lengths are equal. The lengths of u plus v and the lengths of u minus v. Okay, so let us prove this. Well, since we're in R2, let u equal to u1, u2, and vector v is equal to v1, v2. Now, we know that u dot v, which is u1, u2 dot v1, v2, which is u1, v1 plus u2, v2 equals 0. This equals 0. Because that is that is u dot v. And we set it equal to 0. So this equation is important. Now, let's calculate u plus v, and let's calculate the lengths of u plus v and the lengths of u minus v. And using this, let's show that they're equal. So the lengths of u plus v, well, that's the lengths of u plus v. That is, it's the length of u1 plus v1, u2 plus v2. But that's nothing more than the first component squared plus the second component squared square root. Well, the first component squared is u1 squared plus v1 squared plus 2 times u1 v1. Plus the second component squared is u2 squared plus v sub 2 squared plus 2 times u sub 2 v sub 2 square root. And I choose to add those two first. So I have the square root of u1 squared plus v1 squared plus u2 squared plus v sub 2 squared plus. Now when it comes to those two, I can factor out the plus 2. And I get 2 times u1 v1 plus u2 v2. But this is exactly what equals 0. This is exactly what equals 0. That's 0. So we're left with just the square root of that stuff, because 2 times 0 is 0, and adding 0 doesn't do anything. So we have the square root of u1 squared plus v1 squared plus u sub 2 squared plus v sub 2 squared. And that is the length of u plus v. Okay, so now let us figure out the lengths of u minus v. Okay, excuse me. So now, the lengths of u minus v, well, this is the lengths of u, u1, v1, minus the lengths, minus v, which is v1, v2, that should be u sub 2. So it's just the length of u1 minus v1, u2 minus v2. So the length is going to be the square root of the first component squared plus the second component squared. Well, that gives us, this squared is u1 squared plus v1 squared minus 2 u1 v1 plus that squared. That's u2 squared plus v sub 2 squared minus 2 times u2 v sub 2. Well, I want to add those two first. I get u1 squared plus v1 squared plus u sub 2 squared plus v sub 2 squared. And when it comes to those two, I can factor out a negative 2. And I'll have u1 v1 plus u2 v sub 2. But this is 0. And 2 times 0 is 0. That whole piece goes. So you just left with the square root of that. U sub 1 squared plus V sub 1 squared plus U sub 2 squared plus V sub 2 squared. Okay, so this is equal to that. But if you notice, and this is the key part, we got the same answers. Those two are equal, which means that if this and this both equal to this, then these two are in fact equal. Therefore, the length of u plus v is equal to the length of u minus v. That comes from them being equal. Okay, so we proved it in one direction. I suspect you can just read it up to get it in the other direction. But let's actually prove the other direction as well. Okay, so let's write down what it is we want to show. We want to show that the length of u plus v is equaling to the length of u minus v. That implies that u dot v is 0. Okay, but we just shown that. Okay, so let us do this. So the length of u plus v is equal to the length of u minus v. So here we have u1 plus v1, u2 plus v2. That length is going to equal to u1 minus v1, u2 minus v2. But that means that u1 plus v1 squared plus u2 plus v2 squared square root is going to equal to the other side. u1 minus v1 squared plus u2 minus v2 squared. Let's take square roots of both sides. You get this plus that equals to u1 minus v1 squared plus u2 minus v2 squared. Okay. Now, I would like to bring this to the left side, and I would love to bring this to the right side. So the left side now is u1 plus v1 squared, this term, and when I bring this over, it's understood to be plus, so now it becomes minus. Equals. This we're not moving. It's u2 minus v2 squared. And like I said, I'm bringing this to the right side. It's positive. It goes over as negative. Okay. Now remember, whenever you have a squared plus, whenever you have a squared minus b squared, you add the a and the b, and you subtract the a and the b. Excuse me. And you multiply the result. Okay. I have a squared minus b squared. I add these two. I get 2u1 times, I subtract the 2. When you do this minus that, you get 2v1 equals one thing squared minus another thing squared. I add the two things. The v's cancel out. I get u2, I get 2u2, excuse me. And when I subtract them, I get minus 2v2. And these are equal. The first thing I would do is divide both sides by 2 times 2. And now we're 99% done. U1 times V1 is equal to negative U2 V2. Bringing this to the other side, I have U1 V1 plus U2 V2. Well, that's nothing more than U1 U2 dotted with V1 V2. And if you don't believe that, that's cool. Multiply those two, you get U1 V1 plus, multiple, here's the plus, multiply these two, you get U2 V2. Don't believe anything anyone tells you. You want to see it. But this is U dotted with V. U dot V. And one main thing I left out, excuse me, when you bring this to the other side, the left side is now equal to 0. So yep, U dot V is certainly 0. We proved it. Great video, right? Leave a comment. Tell me how much you liked it. Tell me how much you didn't like it. Tell me what you like to see on my channel. Are there any theorems you are just waiting to see me prove? If you have any questions or comments, leave me a comment or a question in the comment section. Most of all, watch and learn.